Stock, Easy Stock is the program that is used by Encompass to keep track of what you have and what you've ordered. You can set up different bin locations. You can set up different locations, whether you just have a truck or whether you have a fleet of trucks. So let's there we go. So let's go ahead and move along. This is a great tool. If you have Easy Stock, I would highly recommend it. I wish they had this whenever I was a service tech. It gives me a better idea of where my parts are. I mean, as far as that, you can actually, if you have tools that you want to keep track of in Easy Stock, you can actually do the same thing. You can keep track of your tools in Easy Stock. You can use the bin feature of it, and you can go ahead and move product and put it where, if you've got different shelves, you can put it on the shelves. If you don't, you can just use a general topic. As long as you check in and out, it's a great tool. Okay. If you want to learn about Easy Stock, this is the YouTube address. Okay. Go ahead and reach out and look on YouTube at that. This is a free video, so it doesn't cost you anything. Go ahead and take care of all of that. Okay. It looks like we got 2 people in the class now. We're going to just keep on rolling. We got a lot to cover in this time that we have. Got to add myself back to the stage where I'm uploading the program again because it decided wanted to just not work right for me. Once it gets uploaded, we're going to move on. Like I said, we got a lot of stuff. One thing I do want to cover, if you notice, I'm not wearing my regular shirt. I'm wearing my my new shirt that Reggie got me. Remember that April 19th is the day that everybody needs to show up over in Lawrenceville. I'm still waiting on this process to go ahead and climb through. But guys, that Easy Stock program, it's great. I mean, absolutely great. Like I said, I wish that I had it whenever I was a technician in the field. I actually have been in this business for quite a few years. As people say, I'm older than dirt. Okay, so let's go back to this. I'm going to give you a second to go ahead and write this down. This email address. I would tell you to please at least take a chance and look at it, because I really think this is a really super program. Okay, so let's go ahead and get started. Let's talk about our 101 basic refrigeration course. This is for 134A systems. It's going to become apparent really quick why it's only 134A. Okay, so one of the things that I start out before I even talk about replacing the compressor. Okay, one of the things that you need to do is you need to be sure that the compressor is actually the problem. Okay, so what tools are you going to need to diagnose the compressor failure? Okay, you're going to need an assortment of hand tools. You're going to definitely need your amp, your multimeter. I have an amp meter that it combines as a multimeter and also combines as an oven thermostat. I would suggest that if you're going to be in this business for a while, you definitely want to invest in a decent amp multimeter. Also, you're going to need a cordless drill and assorted drill bits. So make sure that you have those with you. Don't do like I used to do, and that was put my drill bits in my pocket. And I had a wife at the time, and she used to hate it because those little assorted bits would end up in the washing machine, and I had a problem at one time. Okay, so let's talk about what are our most common compressor issues. Okay, there's an overload failure. Okay, there's start windings failures. There's locked rotors. And then you have just a completed compressor failure, okay? Not only with that, you have a relay that you can have that fails. Now, what are some of the, let's just go and talk about what are some of the causes of a compressor failure? What could lead to a compressor failure, okay? So let's start by what does the compressor actually do, okay? Whenever you come out of the low side, okay, you get a low pressure vapor coming out of the compressor, okay? It goes through the cooling coils, okay? And as it goes through the cooling coils, it changes from a vapor to a liquid, okay? Then it goes through the back side of the refrigerator, goes all the way back down into the condensing coils, and it enters the condensing coils as a high pressure liquid, okay? As it goes through the compressor, as it goes through that condensing coil, it changes once again from a liquid to a vapor, okay? As it enters the compressor on the other side, you got a hot vapor that comes in. It goes through the compressor again, and it comes back out as a low pressure vapor. So what exactly is the function of the compressor? I like to refer to the compressor as a heart. That's all it is. You know what? All it does is pump blood. It's all it does. It moves blood through your body, out, comes back up the other side into the aorta, and you've got your heart. So the compressor is basically nothing but a heart. Okay. I don't know if anybody has ever seen what the inside of a compressor looks like. This is the inside of a compressor. Okay. The compressor, if you notice, you've got your discharge, you've got your low side, you've got you notice there's three places that you can tap into the compressor. One is a stub, and it usually has a little piece, usually about 4 inches off of that you can actually tap into to get a reading for your meter, for your gauges. Okay, so once again, this is the compressor. This is what it looks like. This is the functions, okay? So the suction line comes in. As you notice, it comes down. It goes through a chamber, comes up. There's a motor in it. The motor turns, okay? What does the motor turning do? It actually activates a piston, just like in a car engine, okay? As this piston moves through it, it's moving the stuff into the discharge side. There is a suction valve it's just like actually a car engine. So you have the same thing that you have in a car engine, where you've got valves that open and close. As one valve opens, the other one closes. You notice that there's a suction valve, and then there's a discharge valve. Okay, so the suction valve opens in this position. It sucks it in. The discharge valve is closed. Whenever that suction valve closes, it pushes it compresses the refrigerant, and then the discharge valve opens. It pushes the pushes it out the line, the discharge, and we're backing through the system. You notice there's oil in the bottom. Many of the times this is just like it's almost like a very low oil. One of the things in this compressor that you need to be aware of is there are components in the compressor that make the compressor run. Okay, that to get to these components, if you notice, this is a difficult. You kind of gotta have to wiggle around and get it so you can get it out. It used to be much easier to do it. There was a little clip that you can pop off. Some of the compressors still have that clip. Some of the times you have a little screw that you have to take out. There, you just have to be careful and watch and see what you have to be able to remove this. Now, whenever you do remove this cover, it exposes two components. Okay. The overload that's on the left here, there is a solid state and just a regular old overload. Okay. If you notice the solid state overload has two connectors, and then the regular overload only has one. So whenever this gets pushed into the overload on the left, if you push that into the compressor, we're going to go on down and I'll show you exactly where this goes and what it is. The one on the overload on the right, if you notice, it has only one, but if you look at it, there's a little piece that you push in that's just like the one in the center of the white overload. The start regulator on the right is a very important part. Either one of these can go bad. Let's give an example of, we were talking about what can make a compressor appear to be bad at the start. Okay, let's talk about that. What in your experience have you noticed that something was causing this to cause the overload or the start relay to be bad? What are some of the conditions that could cause that? How about what happens if I have a blanket of hair lint over the condensing coils? Will that cause one of those to go bad? Yes, it will. What happens if I have a fan motor that goes bad? Will that cause it to go bad? A condenser fan motor? Absolutely. If a condenser fan motor goes off and it doesn't affect those, then something's wrong, because this compressor needs cooling to make sure that it doesn't stress out these 2 points. And if it gets too bad, you can actually cause the compressor to seize. We're going to go into that a little bit more. One of the right here is the overload. So how do I check the overload? Okay, as first thing, you're going to unplug the refrigerator. If you want to do it first thing, you can actually check between these 2 points that are on the display. Before I do it, I can actually check my voltage to make sure that I'm getting voltage to the compressor. If I get 110 volts and the compressor's not running, then I need to go farther and check the overload and the start relay. So if I don't have power going to the compressor, I have to figure out why I don't have power going to the compressor. Then you're going to have to go down and you're going to have to look through the board. You're going to have to look through the wiring, all of that. That's not what we're here for today, but I just wanted to bring that up. Okay. So if I've checked these 2 pieces right here, what have I what am I doing? In the next few slides after this, we're gonna discuss how to check the relay and how to check the overload. Okay, so let's go ahead and we're going to talk about. Let's do a quick recap of what we talked about so far. So the compressor is like which part of our bodies? The lung, the liver, the kidneys, the heart. What did I say that I said that the heart was like a compressor, right? So it's D. Okay. Before changing the compressor, what do you look for? Okay. An evaporator coil that's frozen, a frozen suction line, both A and B. Okay. Well, if I have a frozen evaporator coil, or if I have a frozen suction line, I probably don't have I probably know that I don't have a compressor issue, right? So it's actually D, which is none of the above. Okay. In the following diagram, which three terminals come out of the compressor? We haven't gone over this, but the three terminals coming out of the compressor, one is the R, one is the S, or one is the C. So that's the C is a common. That's exactly where the overload goes. Then we have a start and a run, and that's where the relay is going to plug into. Okay, so if we're going to check the relay, all right, how am I going to do it? I'm going to pull it off. Like I said, I'm going to unplug it first. Then I'm going to take all the components out so that I can pull the start relay. I can pull the start relay out, and then I'm going to check it. So, and this is one of the old start relays, but it's going to work the same for the new updated relay. I'm going to check between terminals 1 and 2. I'm going to see if there's any continuity. Okay, if I have continuity, then I'm fine. If I don't, I'm going to change the relay. But one of the other things that I'm going to do is double check. Okay, once I do that, I'm going to put that relay in a vertical position of with the coil of the relay pointed upwards, just like is in this picture right here. Okay, I'm going to check to see if there's continuity between terminals 1 and 3 of the relay. If there's not, okay, I'm going to repeat. I'm going to change the relay, and I'm just going to double check it whenever I put it back in. Okay, before I put it back in. If I get to step 2, one other thing that I can do is with the relay in the vertical position, the coil pointed downwards, so it would be just opposite of what we show here. I'm going to check continuity between terminals 1 and 3. Okay. If I have continuity between those two terminals, then I'm going to change the relay again because I have the relay's bad. Okay. Here's a basic wiring schematic for a compressor. Okay. If you notice here, that's the thermal overload. Then I have the start relay. Okay, which swaps over to the run relay. Both of those are plugged into the compressor itself, just like the thermal protector. Okay, once I pull all these off, what can I do? So I'm going to start here, and I'm going to take my meter, and I'm going to check. I'm going to check between the common and the start, which if you look over on the right side, you see the common and the start, which is on the left. Okay, I should measure between 3 and 11 ohms. Then I'm going to turn and go between the common and the run. There I should measure between 1 and 5 ohms. Okay, then I'm going to go from the compressor pin to the ground, and I should read infinite resistance. The inverter, if it's an inverter compressor, okay, I'm going to get somewhere between 6.2 to to 11 ohms between any of the two pins. So just make sure that you know if you've got an inverter compressor or not. Okay. So I've now gone through and I understand I need to replace the compressor. What am I going to need to replace the compressor? Okay. Right now, there are two different ways to replace the compressor. There is the torch method, which we're going to go through today. And then there's a different method. Okay. Right in the current situation with R600, you're going to need to make sure that you're not using the torch method. If you're in a customer's house, this R600 is highly flammable. It's just about like a big lighter. Okay, so you want to make sure that you don't use a torch on R600. Not only is the R600 in the compressor a little bit, there is between 30 and 40% in the oil itself. So you can actually start an oil fire and have it shooting out the side. I have talked to guys and say, "Oh, I've never had any problems with it. I'm just going to keep using my torch." And I'm going to tell you, if you use a torch with R600, sooner or later it's going to come back and bite you in the butt. Okay. So what I would suggest, there's a new way, and that's the lock ring technology. By the way, lock ring will be at Encompass on the April the 18th, I think is when it is. It's on a Saturday. Come on by. There's going to be plenty of giveaways. There's going to be classes. Like I said, lock room will be there giving a class. But that's not what we're here for today. Today, we're going to talk about this torch and the solder method. Okay. Here is the lock ring method. For the lock ring method, I only need 3 tools. Okay. I could use this on any system. Okay. But what we're going to do is we're going to talk about the torch and solder method. Okay. So what am I going to need to replace a compressor using the torch and solder method? Okay. So this would be just for a hydrofluorocarbon refrigerant. You could use it on any refrigerant that's not R600 or are based with a flammable liquid. Okay. What am I going to need? That I'm going to need pinch-off pliers, which are located down in the corner right here. I'm going to need a system evacuation pump and bag. I mean, pump and tank. I would not suggest using 134A to use the evacuation bag anymore. People still use it. They have good success with it. The problem is you have to turn it right back around and pull that refrigerant out of the bag onto your pump and your tank. So I just tell you to take everything in with you. Okay. I'm going to need a set of gauges. I'm going to need shutoff valves. Everybody knows that with the new EPA guidelines, it's not a $5,000 fine anymore, right? It can be up to a $25,000 fine. I was talking to a gentleman that was with the EPA, and he actually trains on what fines you can incur. And this is per instance. So if they catch you and you've done it 2 or 3 times, they can nail you for all 3. Okay. Don't be silly and just go ahead and do it right. Okay. So use your shut-off valves. You're going to need a vacuum pump. You're going to need some assorted fittings. You're going to need a plier type evacuation tool, some sandpaper, the flux, silver solder. You're going to need a mirror. You're going to need a leak detector, and you're going to need some protective glasses. Please, you don't have to wear them. Please wear protective glasses when you're using a torch. Okay. I didn't wear my glasses, but about 50% of the time. As you can tell, I now wear eyeglasses, and that's directly attributed to from the torch. So please wear your protective eyeglasses. You can buy them. I have eyeglasses now because I learned my lesson as I've gotten older, and I always keep a pair in my truck because I never know when I'm going to have to do it. They have a nice set of glasses that you can, that I actually have a set that are they get a little darker if they're if I'm using the torch. But please, you can buy them on eBay. Please invest in that. Don't be silly. Okay. So before tapping into any system, what should I do? Should I evacuate the system using the evacuation tubing pliers or solder valve? Do I pull a charge into the recovery system if it's anything but R600? That's one of the things that I've got to do. Okay. I've got to do both of those. I've got to evacuate the system. Then I've got to pull a charge into the recovery system as long as it's anything but R600. R600, you can actually disperse it into the air. I would not suggest doing it unless it is unless you have something that you can run a line out a window. Please don't just do it in the house. If somebody's cooking in the kitchen and you just dump it, you could have a problem again with flashback. Okay, so let's talk about flames. Okay, as I'm adjusting my flame on my torch, which flame do I want? Which type of flame do I want? Okay, do I want the carbonizing flame? Do I want a neutral flame? Or do I want an oxidizing flame? I'm going to tell you that if you do anything but using a neutral flame, you're going to run into problems all the way around. Okay. The oxidizing flame is, we're going to go, I've got some slides to show you what happens if you try to use an oxidizing flame in that. If you use a carbonizing flame, you're going to get the soot everywhere. Okay. You want to go with a neutral flame. Okay. Where should the tip of my torch be located whenever I'm trying to solder a joint together? Okay. On a non oxygen acetylene torch, this is the proper place to put it. Okay. If you have an oxygen acetylene torch, that's going to be too close. Okay. That right there is too far. You'll never get it soldered right there. Okay. That is where on an oxygen acetylene torch, that's where I'm going to be, just right at that position. Okay. That allows me to be able to suck the silver solder into the joint. Okay. Where is the hottest location in this flame? Is it where the guy has his finger? Is it up next to the torch head? Or is it over next to where it's being sprayed onto the it's being placed onto the piece that I'm trying to solder? The answer is it goes right at the center. Right in the center of that is the hottest part of your torch. Okay, that's where you want it. Okay, so here it is with a this is like a turbo torch. Okay, it could be a MAP gas torch, but you can solder with this. Okay, as you can see, the hottest point is right there, almost right next to that piece of silver solder is where it is. So I'm going to do that, and I'm going to keep my silver solder rolling around, I want to make sure that I've got that inserted in the right manner. It's going to suck it down into the joint, and then I have it sealed properly. Okay. So here's another question. So out of these two, from what we have learned, which one is the right one? The one on the left or the one on the right? The answer is the one on the left is the proper one, okay? When trying to solder the flame on the left, what happens, okay? If I'm using this method, what benefits do I have, okay? Number one, I can get it done faster, okay? Quicker. It saves on my gas. I can tell you that I had a class that I taught in Memphis, Tennessee on this exact class. We went through a tank and a quarter of gas just for 2 people to go through their oxygen and acetylene. We had to use both tanks, replace both tanks because they didn't have them set right. Okay, so it saves on gas. You don't take as long heating things up. You also are going to remove the amount of oxides that are present in the system. All of those are what you need to do. Okay. The answer is that is number 5, all of the above. Okay. If I use this, see how far off this is? This torch is so far off. This is what happens. If you look, and this will leak like a sieve. Okay. You will not be able to pressurize and get anything. You're going to have to go back and you're literally going to have to clean all of this off with a wire brush. Whenever you get it heat to the right heat, you're going to have to clean it all off. It's going to make a mess on the floor. If you're trying to do this in a customer's home, I will guarantee you that somebody drops some solder on the floor. Okay. Do not do this. All it does is cause you issues. Go back to this method right here. You will never have any problems. You want to be sure that whenever you're doing this, that you're using a blanket to keep the heat off of anything that's inside the refrigerator. Okay. So I'm going to give you these YouTube videos. Okay. These are great videos. These are not mine. They are somebody else's, but I would encourage you to, as you're learning how to do this, before you start on your torch and working with your torch, go and look at every single one of these videos, okay? I'm going to give you a second to write that down. Okay, if you need more time, we'll get to it at the end, okay? So, different tips for different jobs. Okay? Let's talk about tips, okay? This is the one on the left is your standard oxyacetylene torch tip that you get whenever you buy your kit. This one on the left is a torch for a for an acetylene torch. The one on the right is a MAP gas torch. I actually like that one. I actually use MAP gas a lot of times. If I'm not using a large, if it's not a huge sized tubing, I will use that MAP gas torch. Okay, brazing versus soldering. Okay, there's a big difference between brazing and soldering. Go ahead and go to this video. It shows you everything that we don't have time to show today. Okay, go ahead and go to this video. I'm going to give you about 15 seconds to go ahead and do that. Okay, we're going to move on. Okay, brazing copper to copper. That's the easiest brazing that you can do. but you don't understand. You don't know how many people mess it up. If you don't do what we've already said to do in the previous slides, you're going to mess it up and you're going to have a mess. I would recommend that you go ahead and start. This is another really good video that we can use to go ahead and make sure that we're doing things properly. I'm going to give you another 15 seconds to do that. Copy that video down. Okay. Brazing copper to aluminum. This is not an easy task. The only thing worse than copper to aluminum is copper to steel. These two metals, the copper heats at a different rate than the aluminum. You'll end up poking a hole in the aluminum tube if you try to do it like you do brazing copper to copper. You will burn a hole in the aluminum tube, and then you have to start all over. You have to cut the tube. You have to resand it. You have to do everything. Okay. So make sure that you take a little time and go through and watch this video. Okay. And here's the hardest one yet, and that's stainless steel to copper. So take a few seconds and write that down for YouTube. Okay. Before tapping into the system, what should I do? Well, we already did this. For some reason, it went to the, okay. When soldering copper to steel, it is important to heat the copper joint first because it gets hotter faster. True or false? Oh, we got 5 people now. So what does anybody, can anybody answer that question? Okay. Whenever I am soldering copper to steel, do I heat the copper joint first or do I heat the steel joint first? Okay. It's all about which one gets hotter faster. Why don't you put it down in the comment section? I want somebody to at least tell me which one to heat first. Come on, guys, don't go to sleep yet. Okay, so if I'm going to do this, I'm going to heat the copper joint first. Okay. Where should the flame be located when I'm trying to solder? As far away as possible, as close to the joint as possible, just at the blue cone as it enters, as it's the hottest part. Is it A, B, or C? It's C. Okay. What is the name for the fitting that must be removed after you recharge the system? Okay. If I'm a technician, I have to remove this. And you don't know how many times I've been out on a call helping somebody and look, and lo and behold, there's a fitting and it's right there on the compressor and you can't leave it anymore. Okay. Is it called a flux capacitor, a copper valve? I'm sorry, a Schrader valve or a copper valve? Okay. It's B. It's a Schrader valve. And the only way you can get away from that, removing that Schrader valve, is that you use the tool that I showed you. And that's a pinch that requires you to pinch the copper off. Once you pinch that copper off, you're going to have to you're going to have to then take and once you pinch that copper, you can take the pliers off, and you have to pinpoint solder that position so that you actually don't have a leak. Make sure that you check it. Always check anything that you do, any joint you do, anything that you remove. Make sure that you check that at the end before you recharge it. I always use nitrogen. Before I recharge it, I put a little nitrogen in it. I check it, and I make sure that my joints are good. Okay. Why would you not use a torch on a product with R600? Okay. Number one, it's highly flammable. B is you don't really need to use a torch. Don't really have a reason not to use a torch. Number C is the customer asked me not to. The reason is, of course, A, it's highly flammable. Okay. So as we're talking about, this is the old way. This is all of the parts that I am going to need. Okay. If you noticed, I have my gauge set. I have my vacuum pump. I have my shutoff valves there on the one. Then I have my oxygen acetylene torch. I have different fittings for my torch. I have my safety glasses that I wear because I'm using it for a torch. I'm going to need the striker plate so that I can ignite it. One of the questions that I have for you is, if I'm using this striker plate, what do I turn on first? Do I turn on the oxygen, or do I turn on the acetylene? Okay. What do I ignite? What do I use first? Okay, you need to know that before you do anything. Okay. Come on, guys. Somebody answer. Do I ignite the oxygen, or do I ignite the acetylene? Can I ignite both of them? Yes, you can. So if I'm doing this, what would do? I ignite the oxygen, or do I ignite the acetylene? I ignite the acetylene. I turn about a quarter of a turn. I take and use the striker plate, get it to light. Then I adjust it up and pull it in with the oxygen to the tip point that I want. Okay. Then I'm going to go and I'm going to need my silver solder, and I'm going to need my silver solder paste. I typically use the joint because this has a brush built into it. I use that joint, and then I will take the paste and dip that in, because if I have touched anything, the oil on my hands will not allow the silver solder to fall. Will not flow properly. Okay. Once again, these are the tips. I used to have a guy that worked with me that used to love this top left circular tip because it put it right in between, so he got it even on both sides. I had the one that I used for just the acetylene. I mean, just the acetylene torch is this one that's just under that. Okay, the one on the right is your basic tip for an oxygen acetylene torch. You can actually use any of these tips on an oxygen acetylene torch. You just have to know, you have to have the right size. Okay. So there's another picture of the new way. So guys, I have a question. Have you got any questions over what we have been over? Okay. This class was a little shorter than I had anticipated. I had expected to see a few questions and get some answers, but we didn't get that. So let me know if you have any questions. Let me know if you found this useful. Okay. My information is scrolling across the bottom of the screen. Reggie's information is also scrolling across the bottom of the screen. I would really appreciate somebody to drop me a line, letting me know, yeah, I got a lot out of it, or no, I didn't get a lot out of it, and this is why. I am always looking to improve myself, improve my content. I just want to make sure that I'm doing you guys doing you guys justice. So let me know. I do appreciate everybody's time. It was a little shorter than the class was a little shorter. It usually goes for a little bit over an hour and 10 minutes. But since we didn't have any questions, we didn't really run into any issues. But thank you guys. I know that everybody's busy. I know that you got calls that you can probably get out and run now. I want you to be careful, be safe out there. Thank you for your time. And please, guys, if you can come to the Encompass Day. All right. Have a great day. We will talk to you later. Thank you.